Hi, and welcome to Unit 8, Day 5. This video is going to introduce our concept of inverse trigonometry, or inverse trig for short. In the previous lesson, we talked about how to use SOHCAHTOA, sine, cosine, tangent, those trig ratios. And this is the acronym we used to help remember which order we set the ratios up in. The sine ratio is always equal to the opposite leg over the hypotenuse. And remember, we found a reference angle to figure out what was opposite, what was adjacent. The cosine ratio is always adjacent leg over hypotenuse. And tangent ratio is always opposite over adjacent. So we're still going to use SOHCAHTOA in today's lesson. So make sure you have that written down or you remember it from the previous lesson. But first I want to talk about what the word inverse actually means. So when we talk about the word inverse in math, we're referring to operations or functions that undo or cancel each other. And we use inverse operations to solve equations, like this. So the inverse operation of plus 6 is minus 6. Okay, so that's how we get what x should equal. So we do the inverse operation because those cancel each other out. We get that answer. Same thing over here. The inverse of 6 times x is dividing by 6. And so we can use that inverse operation. The inverse of multiply is divide, to solve that equation. And then the inverse operation of a power, x to the second power, we use square roots. Those are inverse operations. So we take the square root of that, and we get, in this case, x equals 6. Just like over here, the inverse operation of dividing by 6 is multiplying by 6. So in this case, we get x equals 66. So we're going to use inverse trig operations, or inverse trig functions, to work backwards in what we talked about. Okay, I want you to remember last lesson we talked about these ratios, sine, cosine, and tangent, and that the sine of an angle equal the ratio opposite leg over hypotenuse. The cosine of that angle equals the adjacent leg over the hypotenuse. And the tangent of that angle equals opposite over adjacent. But today we're going to talk about inverse sine, inverse cosine, and inverse tangent. I'm going to show you where we can find those on a calculator, and I'm going to show you how we write those. So if we know that sine of some angle is equal to a ratio, which we're just going to call x, instead of writing it as a fraction, we're just going to say sine of that angle equals that ratio. To undo that, let's say I knew both parts of the ratio. I knew this side of the equation, and I was looking for a. I'm going to use something called inverse sine. So here's how we would do that. The inverse sine, which we write sine, and then we put a little -1 power after that. We call that inverse sine of the ratio has to equal the angle measure. Here A is the angle measure. And this is the ratio. So here when we do the inverse sine of the ratio, we get the angle. Okay? We can do the same thing with cosine and tangent. All right? If the cosine of A equals x, then the inverse cosine of x equals that angle A. Same thing with tangent. If the tangent of angle A equals x, then the inverse tangent of x equals angle A again. Okay? So we're going to use inverse trig ratios, and I'm going to show you how to find that in the calculator. We can also call these, okay, inverse sine. We write like this, or we could also call it arc sine. Okay, that's another word for inverse sine. Okay, inverse sine we can write like this, or we can call it arc sine. The same thing for the rest of these. Okay, inverse cosine would be written like this, or arc cosine. Tangent inverse, or inverse tangent, could be written this way, or arc tangent. Okay, so that's the ways we can write these inverse trig functions and relationships. So if you need any more time to copy this down, go ahead and do that. Pause the video, whatever you need to do. But we are going to move ahead and take a look at using this in some examples. All right, since sine, cosine, and tangent were used to find missing sides, these inverse trig ratios, inverse sine, inverse cosine, and inverse tangent, help finding unknown angle measures. We're finding missing angle measures. So there's some steps to follow here, and these are what you should have for the 5 steps. Okay, the very first thing you need to do is identify the angle that is needed. That's our reference angle this time. There won't be a given angle measure. We'll need to mark the needed angle, and usually you'll see an X already written there. Then we can label the 2 given sides as either opposite, adjacent, or hypotenuse, only the 2 that we are given, not the 3rd side. Then we can select the correct trig ratio based on SOHCAHTOA, and we can write that equation just like we did the last lesson, but we're going to put an X for our unknown angle. And then we can rewrite using inverse trig to solve, and I'll show you how to do that in these following examples. All right, number 1. We are given this triangle. It's a right triangle. There are 2 sides given, and we are looking for this angle X. Go ahead and mark that as our reference angle. Okay. These sides in relationship to this angle marked with an X, the 21 is the adjacent leg, and the 28 is the hypotenuse. So since we're using adjacent leg and hypotenuse, I'm going to use the cosine ratio because cosine is adjacent over hypotenuse according to SOHCAHTOA. So I'm going to write that equation. I'm going to say the cosine of my unknown angle X equals the adjacent leg 21 over the hypotenuse 28. All right, from this point on, there's some different ways we can work with this. Now, if you end up with a fraction that you can easily identify what it would be reduced to or what it would be as a decimal, then go ahead and do that. Otherwise, just leave it written as a fraction, and we can enter the fraction in our calculator later on. But the next step is to rewrite this equation using our inverse trig. Since the cosine of the angle is what gives me this ratio, then the inverse cosine, and make sure you put that little -1 there, of that ratio has to equal X. And I didn't give myself a lot of room. Okay, let's see if I can fix that for you. Hold on. Okay, and so to find X, this is all we have to put in the calculator. And here's how we're going to do that. Okay. Again, you want to make sure the calculators are set to degrees. All right. If you're using this style of calculator, we can enter it all at once, and it'll automatically open a parentheses for us to use, just like it's written here. Okay. So here's what we can do. We want the inverse cosine, not just cosine. So if you look at the cosine button on your calculator and look really close, above it, written in yellow, is the inverse cosine function. So all we have to do is hit our second button, and then the cosine, and it brings up that inverse cosine relationship. And then we're going to enter 21 over 28, so we're going to use division, 21 divided by 28, and then close the parentheses, and hit equals, and it gives us our answer of what the angle measure must be. And X must be 41.4 degrees. We're always going to round our angle measures to the nearest unit, to the nearest whole number though. Since this is not enough to round up to 42, we're going to leave it as 41 degrees. So we can get an answer that X is about 41 degrees. Okay? So let's try that again with number 2. Again, following our steps, identify the reference angle. Here's your reference angle. We're looking for this X degrees. And so these 2 sides in relationship to that X, 9 is the opposite leg, and 20 is the adjacent leg. These are both the legs. They make up the right triangle, or the right angle in the right triangle. We're not using the hypotenuse. So you should be able to see that we need to use tangent. TOA comes from SOHCAHTOA. So we're going to set up our equation. The tangent of X equals opposite leg over adjacent, so 9 over 20. And now we can rewrite it using our inverse tangent equation, our inverse tangent ratio, that the inverse tangent of that ratio, 9 over 20, is what equals our x value. You're just switching the x and then the 9 over 20 in their place. And so now we just use the inverse tangent function of the calculator again. So we do second, then the tangent button, and then we put 9 divided by 20, and then close parentheses and hit equals. And it's about 24 degrees. So we know x is about 24 degrees. Okay? That leads us to example 3. Same process. We're going to identify the reference angle right there, and then mark these two sides. The 17 would be the adjacent leg, and this 32 would be the hypotenuse. And so to find the value of x, since we're using adjacent and hypotenuse, we're going to use cosine again. So we set up our equation that the cosine of x equals the adjacent leg 17 over the hypotenuse of 32. And then we do we convert this to our inverse cosine. So you write the cosine with a little -1, and then we switch out the 17 over 32 with the x. And that's what we put in the calculator. Second, cosine of 17 divided by 32. Close the parentheses. It equals. And it's about 58 degrees. This 9 after the decimal point tells you to round that up to 58. So that's about a 58 degree angle. All right, our last example is an application problem talking about Jaden. So if you need to pause the video so you can copy this down, I do want you to copy down the word problem in your notes. So give yourself enough time to do that. But it talks about Jaden flying a kite, and he lets out 275 feet of string. And now we're going to assume that that is a very strong wind, so it pulls the string at a perfectly straight line. There's no sag in it, there's no curve to it, it's a straight line. If the kite is 150 feet above the ground, what angle does the string make with the ground? Well, remember, we're using right triangles, so all we have to do is draw this situation where we have the ground, we have the kite string, and then that kite at this point is 150 feet above the ground. So this measurement is our 150 feet. This is our measurement along the ground, and we know how long the kite string is. It's 275 feet. So we have a right triangle. And they ask, what angle does the string make with the ground? They're looking for this reference angle, so put our x there. Well, now it's just a right triangle, and we can use inverse trig. This would be the opposite leg. This would be the hypotenuse. So all we have to do is set up this equation using sine, because opposite over hypotenuse is sine. The sine of angle x has to equal 150 over 275. So I set up my inverse trig equation that the inverse sine of 150 over 275 is what gives me the angle x. And then we put it in the calculator. Inverse sine of 150 divided by 275. That kite string makes about a 33 degree angle with the ground. That is how we use inverse trigonometry to find angle measures.